Hi, this is Allison Covey, and this is my reflection 3. So, the first question that is asked is in Chapter 8 of the book Fundamentals of Cognitive Science by Tom Hardy Leahy, it discusses the three most popular methods used to explore brain processing: positron emission tomography, or PET, magnetic resonance imaging, MRI, or functional MRI, or fMRI. From these options, we need to choose one of these technologies and explain how it works, along with its advantages and disadvantages. I want to talk about MRIs since it's the most commonly used for patients and people already have a good idea about what it is. And in my case, it's very nice to have friends who are in the medical field who've actually have explained how MRIs kind of work to me. So this has definitely helped out for this reflection. So let's first talk about how MRI machines work. The watered down version of an MRI is that it uses radio waves and magnetic fields to create detailed images of what's going on inside the brain. But to dig deeper on that, there are actually 4 different components that make the MRI function as it does: magnets, radio waves, gradient, and of course, we need a computer. So let's first talk about magnets. MRI machines use these large magnets to help identify the water that's in our body. Fun fact is that water has enough magnetic field to where these large magnets, like look how big these are compared to, a regular sized human, can actually detect the water that is in our bodies. From there on, once we are inside the machine, they will essentially search for our water molecules, which are everywhere, since we are made up of 60% of water. So from here, the magnets will be spinning in this direction, helping to be in line with the water molecules that are inside us, and it will align with the magnet inside of the machine. And those water molecules that aren't in sync with the machine will be scanned. Next, we use gradient, which will help adjust the magnetic field strength and divide them into separate parts to specifically target a specific part of the body. Following that, we use radio waves. With these radio waves, it will help move the water molecules and have them go in the same speed or frequency as the magnetic field in the MRI machine. By sending radio waves that match the magnetic field, the low energy water molecules, or the ones that were essentially being scanned, as I was talking about in the beginning, will absorb the energy they need in order to move with the current magnetic field that is spinning in the machine. Once the machine stops giving off radio waves, those low energy water molecules will actually release all their energy that they saved up and return to its normal position. Now, with this new information, it will be sent to a computer in order to be detailed in 3D image. And then from there on, doctors can look at it to see if there's a tumor or etc. This is so cool, and it's done actually by taking images from each section of the body, allowing it to form that 3D so you could see essentially what's all around if you watch like Grey's Anatomy or any kind of any doctor shows. Now, let's talk about the advantages that come along with the MRI machine. According to our textbook, it says that it actually creates a clearer picture of the brain without any harmful rays damaging the brain. But also, MRIs are seen at almost every hospital. It's very easy for each doctor, scientist, etc. to study the brain in real time and develop new treatments, maybe new drugs to treat this plan, or maybe even save someone's life. Plus, the MRIs, again, they don't use any harmful radiation such as X-rays and CTs, which put out a lot of harmful radiation. And of course, finally, it can differentiate between the different tissues actually that make up the idea for both neurological and muscular skeletal imaging as well. Imagine trying to say musculoskeletal imaging. That's pretty hard. Now, let's think about the limitations that come with MRIs. With the advantages, there are also the disadvantages. So, to repair one of these machines, it can cost up to $1,000 actually. I remember doing engineering stuff and I had to do one of these. It costs some good bucks, but I know if one is broken, it can cost up to $1 million. But also, MRIs can take up to an hour just to scan your brain. Plus, you have to be really still while being in the machine. And of course, it can be difficult for people who are like claustrophobic, maybe even young children, or even neurodivergent people. It can take up a long time. And also, ordering this kind of test can't really scan people with metals in their body. So if you got like a knee replacement, you got a rod in your bag, it's really hard to do an MRI scan because you just can't get in there because it's a magnet. I mean, I don't think you want to be stuck in there for a long time. Now, the next question that we have is the embodied cognition paradigm arises as a response to several fundamental principles of classical cognitivism. Identify 3 ideas that classic cognitivism supports but that embodied cognition rejects. For each of these ideas, provide an explanation and discuss the reason the embodied cognition perspective advocates for its rejection. So first, let's talk about the difference between processing information by using simple symbols or codes. With classical cognitivism, we can use various symbols and manipulate them into helping us produce maybe a rule, and even give us an overall answer by continuously using that rule. We can also manipulate symbols to generate a computer program as well. And what we learned about a few weeks ago with the mind-body dualism, the theory believes that the mind and body are separate and therefore acts differently from each other, even in the cases of mental processing, environment, and etc. Now, the embodied cognition rejection. So, this idea is rejected because the mental processing of something can't be explained through symbols and manipulating it. It's really just a part of the physical body interacting with the world around us. We even see it in the readings where it said, and I quote, different behaviors result in different mental states. The reasoning behind this is because when we process these various things through our senses and through our personal experience, we learn more essentially than just following a simple code or simple system. Let's think of it in this way. Think of a kid who grew up in a poor area versus a kid who grew up maybe in a richer area. Their behaviors, their actions, even the way they think, they're going to be completely different because they were influenced by the world around them, not just by the rules. They could be following the same rules, but are they going to get the same result? No. And that's just one of the reasons. Now, I can't find my mouse. Now, second, now let's go back to the idea of body-mind dualism. Again, here we going to do that dualism that we think that the mind individually acts on its own outside of the body's control. And within this realm, the body also acts just basically as a shell according to classic cognitivism. It doesn't really function. It's just there. But with embodied cognition rejection, it says that the mind and the body work as a functioning part. They say they're bonded together, they're linked, they're influenced by each other's actions. Think of it like grabbing a ball. We have to use our mind and our brain to really grab it with even like our thumbs. Like some animals just don't have thumbs. Like, think of that. But also, a better reason to why this is that even like our posture and gesture can be tied to like our brain and our body. For example, let's think about in the classroom. When we can use our hands for multiplication tables, even like fractions. I know I remember doing like my nines that way with my hands to figure out what 9 times 5 is. Oh, that's 45 or something. This shows that all thoughts and learning aren't just with the mind and following this process, but it's also tied in how to use our bodies. It helped us remember, help us grow as a learner. And this is just an example that I could think of where both the mind and the body work together in order to function, to process, and etc. Finally, let's talk about processing information with both classical cognitism and with embodied cognitism. So, as explained in the first video, we talked about the symbols and the codes that were manipulated by them. But we never talked really in depth about executing these codes. I mean, I did a little bit, but let's dive a little deeper into this idea. Well, with embodied cognition rejection, the idea is that it isn't just something that happens naturally, but instead continually is processing and observing things around you. Your thoughts and understanding of the world comes from interacting and engaging with your surroundings, and not just sitting there and talking about various information, such as like x plus y equals z. We understand it, but do we really truly understand it until we can use it in situations that it's actually helpful? The reasoning behind this is that we learn problem solving by exploring the answers to these problems in various ways. We learn from these experiences and reflect on the world, what we should do maybe for next time if we did something wrong, or maybe we should do something differently based on the outcome that happened. For example, we figured out that we're lifting heavy boulders. We need to lift, a heavy boulder, but we can't do it without 100 guys being there. By exploring possibilities of answers, we use tools and pickaxes to help break down this humongous boulder that we have into making it more manageable for people to carry, to move them around without taking an hour or two to move a whole boulder. We can maybe take just an hour. And then from there, we learned maybe we can use machinery like pulleys and heavy machinery in order to do the work for us instead of us working harder or maybe more prone to even get hurt along the way. But overall, it shows that we learn through exploring different options rather than giving your 1, 2, 3 answers that you have to do.